Hi, hello guys, this is Vijay, chemistry lecturer from Alibaug Junior College. As you know that we are doing the NEET series based on that chemistry and biology. We are discussing each and every chapter in detail, and also we are practicing few numericals. Okay. So on that basis today we are going to discuss about few practice problems. NEET chemistry, some basic concept, unit number 1. Examples. So few questions we are going to practice it now. So let us see one by one. Okay, now let us go for the next question. The next question is like a match the following type. Okay, so look at this question guys. Here, yes, here there are two columns given A, B, C, D, E and the other column 1, 2, 3, 4, 5. Okay, so let us see how these answers are going to be matched with the column 1. Okay. So A, 88 gram of CO2 and 6.022 in 10 to the power of 23 molecules of H2O and 5.6 liter of oxygen at STP, 96 gram of oxygen, 1 mole of any gas. So these are the content present in the column 1. The second column you see 0.2 mole, 2 mole, 1 mole, 0.022 in 10 to the power of 23 molecules and 3 mole. Okay, let us see how to solve this problem. Yes. So first one, the column number 1, A, if you see, number of moles we are going to find for the carbon dioxide molecule. Okay. So answer for this question, number of moles of CO2 molecule. Okay. So number of moles, we know the formula that weight in gram given divided by molecular weight of the entire compound. Okay. So weight in gram, that is there in the question, 88 gram divided by molecular mass, okay, molecular weight of the CO2, carbon dioxide. So molecular weight of the CO2, that is 44, yes, 44 gram. So cancelling this gram and simplifying this, we will get 2 mole. Yes, number of moles are 2 mole. So option A, that is closely related to in the second column, second one. So A is matching with the number 2. Now let us see for the second one, B. Yes, so B, here they gave 6.022 in 10 to the power of 23 molecules of H2O. Okay. So how far it is related to the other option? So 1 mole of any substance, we know that is Avogadro number. Yes, Na, capital N and A, Avogadro number. 1 mole of any substance which is equal to 6.022 in 10 to the power of 23 molecules. 6.022 into 10 to the power of 23 molecules. Yes. Now Avogadro number, that is related to what? Avogadro number. Yes. So option B in the column 1, 6.022 in 10 to the power of 23 molecules of H2O, that is equal to 1 mole. So H2O is nothing but it's a compound containing 2 different elements, hydrogen and oxygen. Yes. So collectively it is said to be 1 mole. 1 mole of H2O, that is equal to 6.022 in 10 to the power of 23 molecules. So B, which is closely related to, B is related to option 3. Now let us see the next one. 5.6 liter of oxygen at STP. 5.6 liter of oxygen at STP. Okay. So 22.4 liter of oxygen at STP or any gas. Okay. So 22.4 liter of oxygen or any other gas is at STP equal to, at STP is equal to 1 mole. We know that here we are going to find 5.6 liter of oxygen at STP we are going to find. That means 5.6 liter of 5.6 liter of oxygen at STP divided by 22.4 liter of oxygen at STP. So simplifying this we will get the answer 0.25 mole. So C is related to what? 0.2 mole, that is option 1. Option D, it is matching with the other column. It is 96 gram of O2 oxygen. Okay. So 96 gram of oxygen. Similarly, we are finding this answer like the third one. Okay. So 96 gram of oxygen divided by molar mass of oxygen. So molar mass of oxygen is what? O2. So 2 atoms are there, 2 into 16, that is 32. Yes. Yes. Simplifying this, we are getting the answer 3. So 3 is nothing but 3 mole. Number of moles we are finding. So we are writing 3 mole. D is equal to 5. That is what answer 3 mole. And the last one you see 1 mole of any gas. 1 mole of any gas, just now we have discussed 1 mole of any gas which is always equal to 6.02 to 10 to the power of 23 number of molecules. Okay. So this is 6.022 into 10 to the power of 23 molecules. Okay. So these are the answers for this question. Let us go for the next question. Now look at this next question. This is also a type of match the following. We have to match from column 1 whatever the physical quantities given with column 2 what are the units related to this. Okay. So here are few examples of physical quantities given. If you see options A2H. So first one, that is molarity. So molarity formula, option A in column 1, molarity. Yes, we know the formula for molarity, right? Molarity is nothing but what? Concentration of the solution. So molarity is nothing but number of moles by volume given in liters. Number of moles by volume given in liter. So if you see the unit for molarity, that is number of moles by volume given in liter. So mole per liter is the unit given for the physical quantity molarity. So option A, that is closely related to 5. A is exactly matching with the 5. Option 5, yes, that is mole per liter. Now second one, mole fraction. Yes. So mole fraction, you see, mole fraction, it does not have any unit. It is related to unitless given in the second column. You see option 4, unitless. Mole fraction, there are no unit to be used. Next, mole. So mole, the meaning of mole, and it has a unit. Yes. So mole is nothing but mass of the substance given in gram divided by molar mass of the substance. Molar mass is nothing but gram by mole. Gram per mole. Okay. So that means what? Option C, mole fraction. Sorry. Option C, mole. So mole formula we are writing mole by mole we are going to write the formula for mole. Okay. So mole is equal to, yes, mass of the substance, mass given in gram divided by mass of the substance, mass given in gram divided by molar mass. Molar mass is nothing but gram per mole. Yes, gram per mole. Cancelling the gram I mean they cancelling the mass. What is left over? Mole is left over. So mole is there mole is left over. So the answer is what? Mole. Mole is the unit for option C. So option C here in the second column you see mole. That is what number 2 is given. So this is the answer for this. Now let us see the next one. Yes. Next one is molarity. So molarity that is D exactly matching with the 7. How? Let us see. Yes, molarity is nothing but we know the formula number of moles by mass of the solvent given in kg. Okay. So we have unit for this molarity. Yes. What is the formula? Number of moles per mass of the solvent given in kg. Yes, number of the moles per mass of the solvent given in kg. That is what we are writing, mole per kg. So mole per kg is the unit for the physical quantity molarity. Yes. So the option is 7, mole per kg. Mole per kg. So it is exactly matching. Yes. Next one, pressure. So next option, that is pressure. We know the unit for pressure, that is Newton per meter or Pascal. Yes. So Pascal we are deriving in the form of Newton per meter. So option E, that is exactly matching with the Pascal. Yes, number 3 Pascal. Yes. Next F, luminous intensity. We discussed this one in the physical quantities. You know, the fundamental quantities, basic fundamental quantities. We know the unit for physical quantity, that is candela. We know the physical quantity unit for luminous intensity, that is candela. So option 6 candela. CD we can write it in the form of star form. Next density. So density is nothing but mass by volume. That is the formula. Yes. Density is equal to mass by volume. Mass given in kg per volume given in liter. So this could be further expressed as kg by gram per liter can be expressed into ml. So gram per ml. So this way we can write the unit for density. So density, that is there in G option. So gram per ml. Yes, gram per ml, that is what? Number 1. Gram per ml. So it is exactly matching. And finally mass. Okay. So mass, we know the SI unit for mass. Mass is expressed in the form of kg. So kg where is there in the option? 9th one. So it is matching with 9. So by this way we can match this question. So when we are doing this type of question, first of all we should know the fundamental quantities and derived quantities. Fundamental quantities SI unit and also derived quantities SI unit. So that it is easy to match this type of question. Yes. So let us go for the next question. So now look at this next question, guys. A vessel which contains 1.6 gram of dioxygen at STP. The gas which is now transferred to another vessel at a constant temperature, where the pressure become half of the original pressure. Calculate the volume of the new vessel and number of the molecules of dioxygen. Okay. So first we will find the volume of the new vessel. For that we should do this, whatever the values given in the questions. So let us write one by one. Okay. This question we are going to find with the formula, that is Boyle's law formula, that is P1 V1 is equal to P2 V2. So using this formula we are going to find this question. Okay. So volume of the new vessel we are going to find with this formula. P1 V1 is equal to P2 V2. So Boyle's law formula we are going to use for doing this particular problem. Okay. Let us see how to solve this problem. P1 value, yes, P1 value, that is nothing but 1 atmospheric pressure given in the question. Yes. So 180 m. Then next P2. So P2 is nothing but, yes, P2 is nothing but half of this 1 atmospheric pressure, that is 0.5 atm. Yes. Then T1 is nothing but temperature. Yes, temperature which is given in the question 273.15 Kelvin. 273.15 Kelvin given in the question. Okay, next we are going to find the volume of the vessel. That means V2 and V1 we are going to find. V2 we don't know and V1 we are going to find. So, using these components present in the question, we are going to find the volume of the new vessels. Okay, so first look at this question. 32 gram of dioxygen, 32 gram of dioxygen which occupies the volume at the STP 22.4 liter means, see, 32 gram of dioxygen, yes, molar mass of oxygen 32. So 32 gram of dioxygen, that is occupying the volume, which occupies the volume 22.4. 32 gram of dioxygen which occupies the volume 22.4 liter of the volume, at STP, standard temperature and pressure. That means what? 1 mole of dioxygen. 32 gram is nothing but 1 mole. So 1 mole of any gas which occupy the volume at STP 22.4 liter. Yes. Now, therefore, 1.6 gram of given in the question dioxygen will occupy how many volumes? Let us find. So 22.4 liter into 1.6 gram, yes, 1.6 gram divided by molar mass. Molar mass is what? Molar weight. 32 gram of dioxide. That is nothing but 32 gram. So gram cancel. Yes. Now simplifying this, we will get the answer in volume, liter. Yes. So simplifying this, we will get 1.12 liter. 1.12 liter. Now this 1.12 liter is nothing but V1. So V1 is equal to 1.12 liter. Yes. Gram is cancelled and 22.4 liter of volume. So liter we are writing in the unit. That means V1 is equal to 1.12 liter. This is what V1. Now, from the Boyle's law, as temperature is constant, in the both category you see the temperature which is constant. So, among this any one of this component which is constant, we are using the formula P1 V1 is equal to P2 V2. Okay? So, V2 is equal to, we are going to find for the answer, we are going to find the value of V2. Yes, so V2 is equal to P1 V1 by P2. Just the same formula we are going to find the volume of the second case V2. V2 we are going to find, just we are modifying this formula, same formula. Yes, now let us find the V2. So V2 we are going to find. So first P1 we know given in the question, that is 1 atmospheric pressure, 1 atm into V1, just now we have got the value, yes, 1.12 liter by P2, that is nothing but here given in the question 0.5 atmospheric pressure. 0.5 atmospheric pressure. So atmospheric pressure cancelled. What it is left over, that is volume, liter is left over. So simplifying this, we will get the answer 2.24 liter. This is what V2. V2 is equal to 2.24 liter. Yes. So by this way we can find the volume of the vessel. So volume of the vessel, that is that we are going to find using the formula, Boyle's law formula. P1 V1 is equal to P2 V2. So first let us find the V1. When we know the volume of V1, then we can find the volume of V2. Okay. So by this way we can solve this problem. Let us go for the next question. The next one, B, we are going to find. The same question, we did the answer for A, now we are going to find for B. Okay. Number of moles of dioxygen. Number of moles of dioxygen. Yes. Number of moles of dioxygen. Moles formula. So mass of dioxygen by molar mass of dioxygen. Yes. Mass of dioxygen by molar mass of dioxygen. Number of moles of dioxygen means we are going to find the moles. Yes. So moles formula we are getting mass of dioxygen, mass of the substance by molar mass of the compound given. Okay. Now moles we are going to find number of moles. So moles usually be written as small m. So small m O2 is nothing but number of moles of dioxygen. Okay, we can write it in the simple form. That is mass of dioxygen, mass, that is 16 for oxygen, divided by molar mass. Molar mass, number of atoms in oxygen are 2. So 2 into 16, that is 32. Yes. So simplifying this, we will get 0.05 mole. This is what 0.05 mole is mole. Yes. Number of moles of dioxygen. Now 1 mole of dioxygen. Okay. 1 mole of dioxygen which contain 1 mole of dioxygen which contain number of molecules. We know 6.022 into 10 to the power of 23 molecules. 1 mole of dioxygen which contains 6.0 into 10 to the power of 23 molecules. Now we are going to find for 0.05 mole of dioxygen which contain number of molecules we are going to find. That means 6.022 into 10 to the power of 23 molecules into 0.05 moles. Yes, multiply this, we will get the number of moles, number of molecules present in 0.05 mole. Okay, so simplifying this, we will get 0.3011. Yes, into 10 to the power of 23 molecules. Simplifying this, we will get 0.3011 into 10 to the power of 23 molecules. So this could be written, it is there in the form of decimal. Yes. So this could be written as a significant figure. How to write the significant figure? Reduce 1 digit. That means 3011 into 10 to the power of 22 molecules. Here one digit reduced, so that from the exponent we remove one number. That is 10 to the power of 22 molecules. So by this way we can solve this problem. Yes, we can find the number of moles present in dioxygen. Now let us go for the next question. Let us see the next question, that is calcium carbonate which react with aqueous HCl to give CaCl2 and CO2 according to the reaction which is given below. CaCO3, calcium carbonate in the form of solid, 2HCl, it is in the form of aqueous, and CaCl2, calcium chloride, it is also in the form of aqueous. This is a product, and one more product, that is carbon dioxide in the form of gas, and finally H2O, it is in the form of liquid. So 3 products. There are 2 reactants and 3 products. Okay, now what mass of CaCl2 will be formed when 250 ml of 0.76 molarity HCl react with 1000 gram of CaCO3. Name the limiting reagent, calculate the number of moles of CaCl2 formed in the reaction. So let us see how to solve this problem. So first, answer for this question. First we should find the molar mass of CaCO3, calcium carbonate. Let us find the molar mass of CaCO3, calcium carbonate. So finding the molar mass of calcium carbonate, let us see how many elements are present in this compound. Calcium, carbon and oxygen. 3 elements are there. Yes, calcium, that is 40, plus carbon, that is 12, plus oxygen, that is 16 into 3. Number of atoms are 3. Okay. So the sum of this product, that is 100 gram per mole. So this is what molar mass of CaCO3. Moles of CaCO3 which is present in 1000 gram, that is mass by molar mass. We know the formula for moles. Moles of CaCO3, we are using the formula mass by molar mass. Okay. So now moles of CaCO3 in 1000 gram, that is nothing but 1 kg. 1000 gram. Applying the value in the formula mass by molar mass. So mass, that is given here 1000 gram by molar mass, that is there 100 gram per mole. Okay. Now cancelling the gram and simplifying this, we will get 10 mole. Answer, we will get 10 mole. Okay, so moles of CaCO3 in 1000 gram, that is 10 mole. Now molarity, we are going to write the molarity formula. So molarity, we know the formula for molarity. We know the formula for molarity. Yes. So we know the formula for molarity, right? That is moles of the solute into 1000 by volume of the solution. Moles of the solid here the solid is HCl. So moles of solid HCl into 1000 by volume of the solution. Volume means the entire solution. Yes, entire components present in the solution. Volume of solution. Moles of HCl. N stands for mole. Okay, so moles of HCl. Moles of HCl is equal to 0.76 into 250 by 1000. So simplifying this, we will get 0.19 mole. Okay. Now look at the equation, that is calcium carbonate, that is there in the equation 1 mole. So 1 mole of CaCO3 which is reacting with 2 mole of HCl to produce 1 mole of CaCl2 and 1 mole of CO2, then 1 mole of H2O. So this is the equation. So according to this equation, equation you see, 1 mole of CaCO3 calcium carbonate reacting with 2 moles of HCl. That means 10 moles of CaCO3 will react with, let us see, 1 mole of CaCO3 reacting with 2 mole of HCl. 2 mole of HCl. Therefore, 10 mole of CaCO3 calcium carbonate reacting with, let us see how many moles of HCl. Yes. So 10 into 2 by 1, 10 into 2, 20. So 20 mole of HCl. Yes. But we have got the answer 0.19 moles. 0.19 moles of HCl. Then HCl is said to be what? It is said to be the limiting reagent. Okay. So 1 mole of CaCO3 which is reacting with the 2 mole of HCl. 10 mole of CaCO3 which is reacting with 20 mole of HCl, but we have only 0.19 moles, less than 20 mole. Yes. So that is nothing but the HCl is said to be the limiting reagent. That means 0.19 moles. Okay. So 0.19 mole of HCl which produces how many moles of CaCO3? How many moles of 0.19 moles of HCl that produces how many mole of CaCl2 calcium chloride? Let us see. Okay, 0.19 moles of HCl produces 1 into 0.19 by 2. Okay. So simplifying this, we will get 0.095 mole of CaCl2. Okay. 0.095 mole of CaCl2. That means 0.19 moles of HCl that is producing 0.095 mole of CaCl2. Okay. Now, molar mass of CaCl2, let us see. Calcium chloride, molar mass. Calcium chloride, molar mass. Number of the element present in the compound are 2. Calcium and chlorine. Okay. So calcium, that is 40, plus chlorine, number of atoms are 2. That means 2 into 35.5. Yes. The product what we are getting, molar mass of CaCl2, that is 111 gram per mole. 111 gram per mole. Therefore, finally 0.095 mole of CaCl2, mole of CaCl2 is equal to 0.095 into 111. Okay. Yes. We will get the answer around 1054 gram. So by this way we can solve this problem. Let us go for the next question. Now look at this question. A box contains some identical red colored balls labeled as A, each are weighing 2 gram. Another box which contains identical blue colored balls which are labeled as B, each are weighing as 5 gram. Consider the combinations of AB, AB2, A to B, and A2B3, and so that the law of multiple proportion which is applicable. Okay. For this question, let us make a table. Whatever the content given in the question, let us write. So combinations. What are the different combinations given in the question? AB, AB2, A2B and A2B3. So these are the different combinations. Now mass of A let us see, mass of B let us see. Mass of A that is given, mass of B what is given, let us see. So mass of A that is 2, 2, 4, 4, mass of A, and mass of B that is given 5, 10, 5, 10. Okay, this is the mass of the B. Sorry, 5, 10, 5, 15. Okay, so this is the mass of B given in the question. Now, look at this chart, what we can able to see. It is seen that the mass of the B which combined with the fixed mass of A in different combinations. See, mass of the B that is combining with the fixed mass of A in different combination. Here also see it is fixed, and here the mass of B changed, but mass of A that is fixed. In the next category you see here again the mass of A is fixed, but B changed. The last one also you see mass of the B changed, but A is fixed. So this shows that it is obeying for law of multiple proportion. So according to the law of multiple proportion, you see any one of the compound that is combined with the other compound with a fixed mass. That is what law of multiple proportion. Yes. So by this way we can identify the given data which obey for law of multiple proportion or not. Okay. So by this way we can solve this problem. So finally we have completed thoroughly NEET Chemistry Unit 1 some basic concept chapters in detail. So we have discussed this particular chapter based on the theory part and applications, and also the important formulae and concepts which are related to this particular topic. And we did many numericals from the previous year question paper, and also we did thoroughly the different exemplar numericals from this particular topic as a practice session. Okay. So I hope so this will help you for your NEET preparation, guys. So thank you for listening this. Thank you.